Number 25, y squared equals x squared. Okay, take the square root of both sides. That gives you y equals plus or minus the square root of x squared. I'm not quite done yet, but something I want to point out. You have a negative square root as well as a positive. When you take the square root of both sides, there are negative square roots as well as positive ones. For example, what's the square root of 9? Well, 3 is one of them. But there's another one, negative 3, because negative 3 times negative 3 equals positive 9. So when you take the square root of 9, you end up with 3 or a negative 3. So that's why when you take the square root of both sides here, you have to indicate the positive and the negative square root as well. All right. So what is this? This is equal to plus or minus. Now the square root of x squared is absolute value of x. Now another way of defining the absolute value of x is square root of x squared. So anytime you see absolute value of x, in its place you could always write the square root of x squared, and that's perfectly equivalent. All right. In fact, square root of x squared is one way of defining the absolute value of x. You may not have seen this before, but they talk about it a lot in calculus. All right. Now, what does this look like if you graph it? If you know what the absolute value of x looks like graphed, it looks like a V with the vertex at the origin. All right, that's the positive square root. All right, or rather the positive absolute value. The negative will make all these y values on this graph negative. All right, so instead of positive whatever that y is, it's going to be down here, negative. In fact, all of these are going to be negative. Okay, so it looks like an X when you graph that. I should draw my arrows here so there's no confusion for my axes. All right. Now, you can tell this is not a function. It fails the vertical line test, and any non-zero x value gives you two y values. So you have, if you have one x value, say right here, that is paired with two different y values, here and here. So you have ordered pairs with the same first coordinate but different second coordinates. That means it's not a function. All right. It is a relation, though. It is a relation. The plus or minus gives you that result. All right. If it was just the plain old absolute value of x without the minus, you would have just the v, and that would be a function. All right. The same thing applies to just the negative absolute value of x. The negative absolute value of x looks like this upside down v. And that also is a function, but when you put plus or minus, that makes it not a function. All right, problem number 27. It says, for the following exercises, evaluate the function f at the indicated values, f of negative 3, f of 2, f of negative a, negative f of a plus h. So we have f of x equals 2x minus 5. And first one, f of negative 3. So whatever is in the parentheses there instead of the x, you put into the x in the formula for the function, and then evaluate that, or simplify it. 2 times negative 3 minus 5. So that equals negative 6 minus 5. Negative 6 minus 5 is negative 11. Next one, f of 2. So the 2 goes in the x in the formula. That's 2 times 2 minus 5. So that's 4 minus 5. And that's negative 1. All right. So now we have f of negative a. So you put in the negative a instead of the x, so that's 2 parentheses negative a. And I put it in parentheses always because it tells me where the x was in the formula. Keeps things organized, prevents mistakes that way. All right. This is a simple formula, of course, but you want to keep things simple. Get in the habit of keeping things organized, neat, orderly. And that way you will avoid mistakes when the functions or the formulas become more complicated, which they will, I promise you. All right. So get in the habit now. 2 parentheses negative a minus 5. So 2 times negative a is negative 2a. And minus 5. Now you ask yourself, can that be simplified any farther? No, these are not really like terms, so leave it that way. And then negative f of a. So here, you take f of a and put a negative in front of it. That's basically what you're doing. All right. So this is equal to, now I'm going to use more brackets here, more parentheses, write them as brackets. And inside the brackets, I'm going to put f of a. That's 2a minus 5. So you have different kinds of grouping symbols. Parentheses, brackets, they basically are the same. You could use all parentheses if you want. In fact, if you get into more advanced mathematics, you'll see a lot of that just using parentheses. And it can get a little confusing. So this is why we start you out in math using different kinds of grouping symbols, just so we can keep track of what's going on. All right. This is simplify what's inside. That's just 2a minus 5, so that's minus. Here I'll use parentheses 2a minus 5. And then distribute that negative sign through. If you want, you can think of that as a negative 1 times everything in there instead of just a minus sign. That's perfectly fine. Negative 1 times 2a is negative 2a. Negative 1 times negative 5 is positive 5. So you get negative 2a plus 5. Next, last but not least, f of a plus h. Uh-oh. This has 2 things in it with a plus sign. Oh my gosh. Alright, well, no problem. Just put the a plus h instead of the x. And if you're in the habit of using parentheses like I did up here, it's pretty obvious. 2 parentheses a plus h. And then minus 5. Alright. So again, whatever goes in this here goes into where you see the x in the formula. Okay. And then distribute the 2 through. 2a plus 2h minus 5. I can't do anything more with that as far as simplification, so that's my final answer. Okay, problem 29. We have f of x equals square root of 2 minus x. That 2 minus x is all under the radical, and then outside the radical, plus 5. Now be careful when you write this, especially if you're taking a test and you're writing that down. You don't want your professor or instructor giving you points off for putting the 5 under the radical. Don't extend this radical line over the plus 5 because it doesn't belong there. Now if you want to avoid all possibilities of confusion, you would put the 5 first. 5 plus square root of 2 minus x. This is equivalent to this, and there's less confusion. You can definitely see the 5 is not under the radical. All right, it's not in the radicand. So that's an alternative way of doing it, and there's less confusion that way. So it's your choice as to how to write it. If you write it this way, be careful about how far you extend this radical sign. And now let's see, f of negative 3 equals square root of, instead of the x you write a negative 3. It's going to be 2 minus negative 3. So here parentheses really help. And then plus 5. Alright, so that's equal to, minus a minus is plus, so that's square root of 2 plus 3, and then minus, or plus 5. And square root of 5 plus 5. Now you can't add those, it's not square root of 10. Alright, so don't do that. Square root of 5 and the 5, you can't add those. They're like unlike terms. Alright, so you just leave it be. You could get a decimal approximation for what that is by punching it into your calculator. Alright, and then we go to f of 2. I'll let you do that though. I'm going to move on. F of 2 is equal to square root of 2 minus 2. And then plus 5. So that's square root of 0 plus 5. Square root of 0 is just 0 because 0 times 0 is 0. Alright, so it's just 0 plus 5, which equals 5. Okay, so there you go with that. F of negative a. That's square root of 2 minus negative a. Plus 5. Minus a minus is plus, so that's square root of 2 plus a. Plus 5. And that's about all you can do with that one. And then minus f of a. So on this one, just like the one we did before, you put a minus in front of f of a. So that's minus, I'll put this in brackets here. What's f of a? Square root of 2 minus a plus 5. Don't really need parentheses in this one. And that equals, think of that again as being a negative 1, if that makes you feel better. Negative 1 times everything in there. Distribute that through. That gives you negative 1 times that, which is negative square root of 2 minus a. And then negative 1 times 5 is negative 5. So it's negative square root of 2 minus a minus 5. And then finally, finally we have f of a plus h. My clearing my throat is a trick to get you guys to stay awake. Just kidding. All right, so we've got f of a plus h. Put the a plus h in the x up there. But watch out. 2 minus x. What's the x? It's a plus h. So minus parentheses a plus h. Just like that. Okay, again, that's where the x went before in the formula. But instead of x, you're putting in all of that, a plus h. So put the parentheses around it because you're subtracting all of this. You know, you were subtracting the x, but the x here has two terms, so you're subtracting all of it. So that's why you put parentheses around it. Okay, this is and then plus 5. So that's equal to, again, you can think of multiplying by -1 here. -1 times a and -1 times h. All right. So it's 2 minus a minus h. Plus 5. So there you go. All right, we have number 31 here. And f of x, oh my goodness, absolute value bars. The horror of algebra students, right? The horror, the horror. Not a big deal in this one. Absolute value of x minus 1 minus absolute value of x plus 1. All right. This is going to take some space here. Let's see. We have f of -3. So everywhere there's an x, you put in -3 in the formula. Right there and right there. All right, so we've got absolute value of -3 minus 1 minus absolute value of -3 plus 1. And then we've got -3 minus 1 is -4, so absolute value of -4 minus absolute value of -3 plus 1 is -2. Absolute value of -4 is 4, and then you've got the minus there. Absolute value of -2 is 2, so you got 4 minus 2, which equals 2. All right. Okay. I've got room for another one here. F of 2. Absolute value of, put a 2 in here and there. So you've got absolute value of 2 minus 1 minus absolute value of 2 plus 1. So that's absolute value of 2 minus 1 is 1 minus absolute value of 2 plus 1. 2 plus 1 is 3. Absolute value of 1 is 1 minus absolute value of 3 is 3. So this is equal to 1 minus 3, which is -2. Okay. There you go. Now let me erase this so I can have room for the others. Okay, f of -a. That equals negative a here and here. All right, so you got negative a, absolute value of negative a minus 1, minus absolute value of negative a plus 1. All right. Now, the answer in your book is this, but there is a little more you could do with this. Just for instructional purposes, maybe you might learn something from this. I'll show you what else you could do with this. All right. So this is equal to absolute value of. Now on this one, you can factor out a negative 1 over these two terms here. So you could think of it like this. Put a negative 1 or just a minus, parentheses, a plus 1. I could factor a negative 1 out of these two as well. That would be a minus, parentheses, a minus 1 if I wanted to. But there's really no point in doing that, so I'll just leave it the way it is. I'm just going to focus on the first term in this expression. So this is a minus, think of that as a minus 1, multiplying. So I just factored a minus 1 out of these two terms. All right, maybe you haven't thought of doing that before. So sometimes this comes in handy in other expressions, this little technique. Now here I've got this negative 1 times parentheses a plus 1. If you have absolute value of a times b, you can write that as absolute value of a times absolute value of b. All right, that's a rule that you can use. So I'm going to do that here. I'm going to write absolute value of negative 1 times absolute value of a plus 1 minus absolute value of minus a plus 1. Now the absolute value of negative 1 is positive 1. So I can just leave that blank and just write absolute value of a plus 1. Minus absolute value of negative a plus 1. All right. So as you can see, the absolute value of a plus 1 is equivalent to the absolute value of negative a minus 1. So you can prove that by just going through these steps. All right. You can go this way or you can go in this direction, either direction. So they're equivalent. All right. So sometimes that helps when you're simplifying your work, or if your book has an answer different from yours but you thought you did it correctly. When you involve absolute values, you can do that and you'll see that maybe your answer was equivalent to the book's. So if this was your answer and you saw that in your book, which you will, you'll know that you did it correctly and your answer is equivalent. And if you did this on a test, your teacher should give you full credit for that. And if he or she doesn't, then they need a refresher course in math, okay? And you can show them how you did it and prove it to them. Okay. I need to have more space now. So we have negative f of a. So you put a negative in front of everything involving f of a here. I'll put brackets there. And you've got f of a, that's absolute value of a minus 1 minus absolute value of a plus 1. Or you could use parentheses too. And then that equals, think of that as a minus 1 multiplying those two terms. Minus 1 times that is minus absolute value of a minus 1. Minus 1 times this minus, you can think of that as a minus 1 there if you wish. Minus 1 times minus 1 is plus 1, so that becomes plus absolute value of a plus 1. Alright? There you go. And then f of a plus h, seems like I'll need a lot of room for this, but it turns out that it does not require that much space, because there's not too much simplifying that can be done with this. Now you put the a plus h everywhere you see the x's in the formula, here and here. So you've got a plus h instead of the x, and then minus 1 in the absolute value bars, and then minus absolute value of a plus h plus 1. That's about all you can do with that expression. Alright, so that's all the room we need for that one. Alright, number 33. It says, given the function g of x equals x squared plus 2x, evaluate g of x minus g of a all over x minus a, where x does not equal a. Why do they specify x not equal to a? Because if it did, then you'd have a minus a in the denominator, which would be a 0 denominator. And of course, that's undefined. Alright, you can't do anything with a 0 in the denominator. That's not a real number, and so that's why we say it's undefined. It's undefined in the real number system. Okay, so we've got g of x is equal to x squared plus 2x. So we want g of x minus g of a all over x minus a. And x is not equal to a. So we have g of x first, so we write that down in the numerator, x squared plus 2x. Then you subtract g of a, so put minus, and then the whole g of a. That's got two terms, so you put it in parentheses. If you don't, it's wrong. Alright, if you just put the a squared plus 2a there without the parentheses, you're just going to be minus the a. You're just going to be doing minus the a squared, but not the 2a. So that would be incorrect, and that might be, if you did this wrong, might be where you made a mistake. So you need to put it in parentheses. Here in mathematics, parentheses count for something. So we've got g of a, that's a squared plus 2a. So again, you put all that in parentheses, all right, and subtract. And down here you've got just x minus a. So we have x squared plus 2x minus, and again, you can think of that as minus 1 multiplying whatever's in the parentheses. That's quite alright. Minus 1 times a squared and minus 1 times 2a. Alright, so you get minus a squared minus 2a all over x minus a. Alright, so now we can get the, let's get the x squared and the minus a squared together. Why? Because I see something we can factor. X squared minus a squared. Difference of squares, right? So I'm going to group those together using commutativity here. Commutativity of addition. X squared So this is plus a minus a squared. That's the commutativity of addition. Alright, so you can switch that around. X squared minus a squared. And then we've got plus 2x minus 2a. I'll put those two together because you can factor out the 2 there. Then we've got x minus a. So you're looking for things you can group together to factor out and possibly simplify the expression. Alright, so this is, I'll just group those together in parentheses, x squared minus a squared plus factor the 2 out, and then x minus a over x minus a. So this is the difference of squares. That's x plus a, x minus a, parentheses x plus a, parentheses x minus a, plus 2 parentheses x minus a over x minus a. Alright, now you can remember this situation from factoring by grouping. Alright, you've got a common factor of x minus a there and there on these two terms. Alright, so you factor out the x minus a, bring it out in front. Lo and behold, I can already see what's going to happen. That's going to cancel with the denominator, but let's wait till we get there. So that leaves me with, when you factor out the x minus a, that leaves you with the x plus a, and then plus the 2, all over x minus a. Now I can do some canceling. See, what you really have here is x minus a over x minus a. Let me write it over here. Times x plus a plus 2. This is a factor of 1. So we can basically ignore that. We can ignore it safely because x does not equal a. So if it did, then we'd have 0 over 0, which also is undefined. All right. So since it doesn't equal a, we don't have to worry about it. So this is equal to 1, so we can cancel. And remember, canceling doesn't mean it becomes 0, it means it's 1, and we can ignore 1 times this because 1 times that equals that, right? So we don't have to write 1's there. So that's just x plus a plus 2. And there you go. Okay, we have number 35. It's a two-parter. Given the function f of x equals 8 minus 3x, a, evaluate f of negative 2. So let's write f of x here. 8 minus 3x. So part A, f of minus 2. So that equals 8 minus 3 times minus 2. Okay, order of operations, you multiply first, so that equals 8 plus 6. 8 and a negative 3 times negative 2 is positive 6. Alright. You do not go a minus 3 is 5, 5 times negative 2 is negative 10. If you did that, you're not following the order of operations. So, order of operations say you do the multiplying before you do the adding or subtracting. Alright, so you multiply the negative 3 and the negative 2 and get positive 6. So it's 8 plus 6. Alright, so don't make that error. And then that equals 14. Okay, and then that takes care of A. Part B. Solve f of x equals -1. Alright, so f of x is 8 minus 3x, so you write that down. 8 minus 3x equals -1. Now you want to solve this. Solving it for x, right? Because that's the variable there. So this one's a pretty easy one to solve, right? This is like Algebra 1 stuff. Subtract 8 from both sides, or move the 8 to that side, change it to a negative. So you get -3x equals -1 minus 8. And that equals -9. So you have -3x equals -9. That means x must equal 3. Divide both sides by -3, and that gives you +3 here. -9 divided by -3 is +3. Or on this one, you could just do it in your head. All right, it's pretty simple. -3 times what equals -9? Well, it must be 3. Okay. All right. Number 37. Given the function f of x equals x squared minus 3x, evaluate f of 5, that's part A. And part B, solve f of x equals 4. So let's do part A. First of all, f of x, again, is x squared minus 3x. Part A. F of 5. Evaluate that. Well, that evaluate means to calculate it or compute it or things like that, right? So we've got 5 there and a 5 there, all right? So that's 5 squared minus 3 times 5. 5 squared is 25. Minus 3 times 5 is 15, so it's minus 50, actually minus 15. So minus 3 times 5 is minus 15. So 25 minus 15 is 10. There you go. Part B. We have solve f of x equals 4. So what's f of x? It's x squared minus 3x. That's equal to 4. Bring the 4 to the left side of the equation. X squared minus 3x minus 4 equals 0. Okay. Now these, this is factored into x plus 1, x minus 4. Equals 0. So either this factor or this factor equals 0, because 0 times whatever equals 0, or whatever times 0 equals 0. And so that means x plus 1 equals 0, or x minus 4 equals 0. So there we go there. And then x equals -1, or x equals positive 4. There you go. Okay, number 39. Consider the relationship 3r plus 2t equals 18. Part A, write the relationship as a function. R equals f of t. Alright, so let me write this relationship down. If I can avoid making stray marks, that would be nice. Alright, so 3r plus 2t equals 18. So part A is we want to write a function of this as r equals f of t. In other words, we want to write r equal to some function of t. Alright? Or some function, you might see it worded as some function in terms of t. Okay, that would be the same thing. So basically what you do is you take this formula here, this relation, and just solve it for r. r equals blah blah blah, and the blah 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 part will have t in there somewhere, right? Or maybe in more than one spot. In this case it's just one spot. So then you have a function of t, right? A function involving t. And you'll have r equal to this function involving t. Okay? That's what you're doing when you isolate the r here. So you take this 3r plus 2t equals 18. And we want to again solve this for r. So you got 3r equals negative 2t plus 18. So subtract 2t from both sides. Or think of it as transposing the 2t, changing the sign on it to negative 2t to the other side there. And then you multiply both sides by 1/3 or divide both sides by 3, either way. Alright, so you got 1/3 times 3r equals 1/3 times negative 2t plus 18. So dividing by 3 is the same as multiplying by 1/3. That's another little fact you can use sometimes to help you solve problems. If you don't want to divide, just multiply, all right, by the reciprocal. So 1/3 times 3 is just 1. So these cancel, right? Again, canceling doesn't make it 0. It makes it 1, all right? 3 over 3. So that just leaves you with r. We're ignoring a factor of 1 by canceling. 1/3 times negative 2t is negative 2/3 t, or 2t, negative 2t over 3, either way. I'll just write it like this, negative 2/3 t. And then 1/3 times 18, that's 18 divided by 3. If you will go 1/3 times 18 over 1, that's 18 over 3, which is 6, all right? So we've got plus 6. So r equals negative 2/3 t plus 6. So we've just written r as a function of t. r as a function with t in it. Okay, there you go. Let's do part B. Evaluate f of negative 3. F of negative 3. Well, what's f? I don't see any f's up here. Oh, wait a minute. We just did that, didn't we? F of t, huh? There's f of t right there. Well, okay. Just use this expression for f. So, what do we got here? Negative 2/3 times t, which is negative 3. Plus 6. So there's f of negative 3. These cancel. The negative times negative is positive, so that gives you a positive 2 plus 6, which is 8. There you go there. And then part C, solve f of t equals 2. I'll do that over here. Let me divide this. Part C. F of t equals 2. So f of t, once again, is negative 2/3 t plus 6. Yeah. Starting to get sloppy here. I think after this I'm going to have to quit and have some coffee. And then resume this later. Okay, so once again, negative 2/3 times 2 plus 6. There's f of t. Oops. I had 2 on the brain there. Thinking ahead, that's what gets me in trouble when I'm doing board work. I think ahead as to what I have to do next, and then I put down what I'm thinking about. I was thinking of putting equals 2, and then I put the 2 inside of there. Okay, sorry about that. That's f of t is negative 2/3 t plus 6, and set that equal to 2. There we go. Alright, now we're set. So you subtract 6 from both sides. So you get negative 2/3 t equals 2 minus 6, which is negative 4. Then I want to clear the fractions here. So you multiply both sides by the reciprocal of negative 2/3 to clear that. So I multiply by negative 3/2 on both sides. Let me get that parentheses out of there. So I've got negative 3/2, which is the reciprocal of negative 2/3. Equals negative 3/2 times negative 4. Alright. And you got canceling going on here, and negative times negative is positive. So that just gives you a t, which is what we want, on the left side. And here you can cancel, well, you cancel the 2 and the 4. 2 goes into 4 2 times, so that becomes a 2. Negative times negative is positive, so what you get is 3 times 2 is 6. So t is equal to 6. Okay, number 41. Here we're supposed to use the vertical line test with these functions to determine which graph shows relations that are functions. So 41's got something that looks kind of like this. And if you do the vertical line test, you'll see that the line will hit more than one time. You could do it over here. If you do it right at the vertex, right along the y-axis, it'll only hit once. But that doesn't work, because if you draw a vertical line in other places, it will hit more than once. So that's all it takes for it to fail the vertical line test. All right. If you can draw a vertical line in one spot, just one spot where it hits more than once, then it's not a function. All right. Okay, so this is no. Number 43. And so we have something that looks kind of like this. Alright. So anywhere you draw a vertical line on this, it only touches one time, right? Here, here. So this does pass the vertical line test, and it is a function. Number 45. So something like that. And if you draw vertical lines, it'll only hit one time. Alright, we're assuming that this keeps going in a non-vertical way here and here. All right. So there you go. If it ever did reach a vertical way, which it won't, we're assuming it won't, then it wouldn't be a function. But this one looks like y equals x cubed. All right. So that is a function. Number 47. And it looks like we have a straight line. And of course, straight lines are functions, all right? Except where you have a vertical straight line, of course. X equals some constant, all right? That would not be a function. It's a vertical line. Or a vertical line drawn through that vertical line. Here's your vertical line. If you do the vertical line test, it hits an infinite number of times. So it's definitely not a function. All right, but this one's okay. It's slanted, and so vertical line test works on this one. Number 49. And here we have a straight line again, slanted in the other direction this time as compared to 47. So again, draw vertical lines anywhere you want. It'll hit only one time. So that is a function.